Welcome to the peaceful space of sleep-friendly science where we drift among the countless stars, pondering the quiet vastness of the cosmos and the profound questions it holds for us. Have you ever gazed at the night sky and felt a sense of gentle wonder, but also a profound quiet? Tonight, we delve into that cosmic silence, asking a simple yet immense question. In this endless expanse of stars and planets, where is everybody? Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Cosmic Equation of Loneliness. The journey begins here, in the quiet of your own space, with your own breath. Feel the gentle rise and fall of your chest, a silent rhythm that connects you to the universe. Now let your mind drift upward, past the ceiling, past the thin veil of our atmosphere, and into the endless, silent dark. Picture yourself floating in that perfect blackness, a single, conscious mote of dust in an ocean of stars. From this vantage point, the Earth is a swirl of blue and white, a precious marble of life hanging in the void. But as you drift further away, it shrinks, becoming just another point of light, indistinguishable from the countless others that surround you. Here, in the grand amphitheater of the cosmos, you are looking at a spectacle of unimaginable scale. Our home galaxy, the Milky Way, is a sprawling, spiral city of light. It contains, by conservative estimates, over 100 billion stars. 100 billion suns. Think of that number. If each star were a single grain of sand, you could hold the stars of our galaxy in a large bucket. But the Milky Way is not alone. It is just one island of light in a cosmic archipelago. Through the deep space telescopes that act as our eyes into this abyss, we can see other galaxies, billions of them, each one a similar collection of billions of stars. If you were to count every star in the observable universe, one per second, it would take you trillions of years. The number of stars is greater than all the grains of sand on all the beaches of Earth combined. And we now know that stars are not solitary wanderers. They are more often than not parents. They are surrounded by families of planets drawn into an elegant gravitational dance. The Kepler Space Telescope taught us that planets are not a rarity, they are the rule. Nearly every star you see in the night sky is likely to have at least one planet orbiting it. Many have more. So, the raw materials for life are not scarce. The potential homes, the cosmic real estate, are abundant beyond all comprehension. Billions upon billions of rocky worlds, gas giants, and frozen moons. Trillions of cradles waiting for a spark. In this vast, stardusted ocean, it seems statistically inevitable that life would arise not just once, but over and over again. That some of those life forms would, like us, eventually gaze up at their own skies, their own stardusted oceans, and wonder if they were alone. It seems the universe should be humming with the signals of 1,000 different conversations, a symphony of civilizations. And yet all we hear is silence. This is the great, haunting question of our time. It is known as the Fermi paradox, named after the physicist Enrico Fermi, who, during a casual lunch conversation, is said to have asked a simple, yet profound question: where is everybody? To give structure to this question, to give shape to our wondering, the astronomer Frank Drake crafted a beautiful thought experiment in the 1960s. It isn't a rigid calculation meant to provide a single, correct answer. Instead, it is more like a poem or a piece of music. It is a sequence of questions that guide our imagination, a scaffold upon which we can build our dreams of other worlds. It is called the Drake equation. Let us walk through it together, not with calculators, but with a sense of gentle curiosity. It begins with the birth rate of stars in our galaxy suitable for hosting life. Imagine a vast, cosmic nursery where clouds of gas and dust collapse under their own weight, igniting into brilliant suns. The equation asks, how many new, stable stars are born each year? Our galaxy is not a static museum. It is a living, breathing city, constantly building new stellar homes. The number is thought to be surprisingly small, perhaps just a few new suns each year, but over billions of years, this steady creation has filled our galaxy with opportunities. Next, the equation asks, of those new stars, what fraction have planets? As we've discovered, this is no longer a wild guess. The answer appears to be most of them. The cosmos, it seems, loves to make planets. It is a natural, beautiful consequence of making stars. Then comes the most hopeful part of the journey. Of those planetary systems, how many have a world that could actually support life as we know it? This is the famous Goldilocks zone, a region around a star where a planet is not too hot and not too cold for liquid water to exist on its surface. It is the cosmic shoreline where the gentle waves of a potential ocean could lap. These are the worlds that are just right. And we are finding them. We are finding more and more Earth-sized planets in the habitable zones of their stars. They are out there, waiting. Now, the equation takes a turn into deeper, more mysterious waters. On a suitable planet, what is the probability that life will actually arise? This is the leap from simple chemistry to complex biology. The spark, the miraculous moment when non-living matter organizes itself, replicates, and begins the long, slow journey of evolution. Is this leap a cosmic inevitability, a natural outcome given the right ingredients and enough time? Or is it a fluke of unimaginable rarity, a chemical accident that happened here on Earth but perhaps nowhere else? We have only one data point, ourselves. It happened here. But was it easy? Was it hard? We simply do not know. But let us be optimistic. Let us assume the spark of life is not a miracle but a common occurrence. The equation then asks, on those worlds where life takes hold, what fraction of it evolves to become intelligent? Think of the billions of species that have existed on Earth. The dinosaurs ruled for 150 million years, but they never built a radio telescope. Intelligence, the kind of consciousness that can contemplate the universe, may be an incredibly rare adaptation. Or perhaps it is a common evolutionary pathway, a tool that eventually emerges on any world with complex life. Then, for those civilizations that do achieve intelligence, what fraction of them develop the technology and the desire to communicate their existence to the cosmos? To send signals out into the great, silent night? A civilization could be deeply philosophical, artistic, and wise, yet never feel the need to shout into the void. They might be content to simply exist on their own world, their own island of thought. The desire to broadcast, to seek out others, might be a uniquely humane or uniquely lonely trait. Finally, the Drake equation arrives at its most sobering and perhaps most important term. For the civilizations that do try to communicate, how long do they last? This is the variable L, the lifetime of a communicating civilization. Do they survive for a few thousand years before succumbing to war or climate change or a cosmic catastrophe? Or do they overcome their adolescent challenges and endure for millions, even billions of years, becoming stable, immortal gardeners of their star systems? The answer to this final question dramatically changes the outcome. If civilizations last for only a few centuries, then even if thousands have existed throughout the galaxy's history, the chances of any two existing at the same time are infinitesimally small. The cosmic ocean is vast not just in space, but in time. We could be listening for a signal from a civilization that died out 1 billion years ago, or waiting for a call from one that will not be born for another million. We could be like two people trying to meet in a massive, ancient city, but with no clocks, arriving at the same spot on different days, different centuries, destined to miss each other forever. When Frank Drake and his colleagues first ran through this equation, their optimistic guesses suggested that our galaxy should be teeming with civilizations. There could be thousands, perhaps millions of them right now. And so we are left with this deafening contradiction. An equation that predicts a chorus and a universe that offers only silence. A sky full of lighthouses with no one turning on the lights. This is the heart of the paradox. This is the cosmic equation of loneliness. The silence itself is a message. It is a piece of data. It whispers to us, posing a new set of questions. Is our math wrong? Are our assumptions too hopeful? Or is there something else at play? Something we haven't considered? Perhaps the silence is not empty. Perhaps it is a warning. This is where our true journey begins, into the possible reasons for this great silence. We must now become cosmic detectives, sifting through the clues, exploring the hypotheses, each one more fascinating and more chilling than the last. we must confront the possibility that the universe is far stranger and perhaps far more dangerous than we have ever dared to imagine. Section 2. The Great Filters of Genesis. And so we stand before this great silence, not with fear, but with a quiet, reverent curiosity. To understand this emptiness, we must first understand the concept of a great filter. Imagine the evolution of life as a long, winding path stretching from a lifeless rock to a galaxy-spanning civilization. A great filter is a gate on that path, a wall so high, a chasm so wide that almost no one who attempts to cross it succeeds. It is a challenge so immense that it effectively sterilizes the universe, silencing the cosmic chorus before it can even begin to sing. The terrifying and fascinating question is this: where on the path is the filter? Is it far behind us, an obstacle we have already miraculously overcome? Or does it lie in our future, an unseen precipice towards which we are blissfully, inexorably walking? Let us for now turn our gaze backward. Let us walk the path of our own deep past and look for the filters that lie in the genesis of life itself. Perhaps the silence of the universe is not the silence of a graveyard, but the silence of an empty nursery. Drift back in time with me for billion years. The earth is not the gentle blue marble we know. It is a violent, chaotic world, a Hadean nightmare. The sky is a bruised orange, thick with unbreathable gases. Volcanoes constantly tear the surface apart, spewing lava and steam. The oceans are not blue, but a murky, iron-rich brown. A chemical soup bombarded by relentless meteorites and crackling with the raw energy of primordial lightning. This is the crucible. This is the stage. The first and perhaps the greatest of all filters is the very beginning, the origin of life itself. Abiogenesis. The transition from non-life to life. We take it for granted because we are here. But consider the leap. In that chaotic, chemical ocean, simple organic molecules were forming amino acids, nucleotides, the building blocks. But a pile of bricks is not a house. A collection of letters is not a poem. Life is not just about the ingredients, it is about the arrangement. It is about information. For life to begin, these molecules had to somehow arrange themselves into a structure that could do something miraculous. Make a copy of itself. A self-replicating molecule. Imagine a storm of Scrabble tiles, and in the chaos, a single sentence forms by chance. Now imagine that sentence, when jostled, magically summons the correct tiles from the storm to form an exact copy of itself. And then those two sentences make two more. The improbability is breathtaking. It is a leap from simple chemistry to information technology, a software that can run on the hardware of physics. Perhaps this is it. Perhaps this is the great filter. The spark of life may not be a common chemical reaction, but an event of such staggering improbability that it has happened only once in our entire galaxy. Once in 4 billion years on one small, wet rock orbiting an unremarkable star. If this is true, then the universe is not empty, it is simply sterile. It is filled with beautiful, intricate, but lifeless worlds, cosmic art galleries with no one to admire the paintings. If this filter is behind us, then our existence is a prize won against odds of 1,000,000,000 to 1. The silence of the universe is the sound of a lottery that has had only one winner. You listening to this are a descendant of that single, miraculous spark. Every cell in your body carries the legacy of that first, trembling act of replication. Feel the weight and the wonder of that. We are not just alive, we are the embodiment of a statistical miracle. The universe is silent because we are the first, lonely voice preparing to speak. But let us be hopeful. Let us imagine the spark is not so rare. Let us say that simple life bacteria, archaea, the microbial mats that are the pioneers of biology is common. Let us imagine a universe teeming with microscopic life, a galaxy where countless worlds have cosmic pond scum. Is the path to intelligence then clear? No. Here we encounter the next potential filter, a wall so high it took life on Earth nearly 2 billion years to climb it. For half of life's history on this planet, it remained as simple as it could be. Prokaryotic cells. Tiny, simple bags of chemistry, with their genetic material floating freely inside. They were masters of survival, blanketing the planet, even changing its atmosphere. But they were stuck. They lacked the internal machinery for true complexity. Then, something extraordinary happened. A singular event, a moment of such importance that it redefined the future of all life on this planet. It was not a battle, but a merger. Pact. One simple cell, a predator, engulfed another, smaller one. But instead of digesting its prey, it formed a partnership. The smaller cell, a specialist in generating energy, was given a safe home and raw materials. In return, it became a power plant for its host. This ancient, swallowed bacterium became what we now know as the mitochondrion. This merger created a new kind of being, the eukaryotic cell. Your cells, my cells, the cells of every plant, animal, and fungus on Earth. It was like the invention of the city. The simple prokaryotic cell was a lone hut, a tiny, self-sufficient homestead. The new eukaryotic cell was a bustling metropolis, with a central nucleus to protect its precious genetic library and countless mitochondrial power stations churning out vast amounts of energy. This surplus of energy changed everything. It was the fuel that allowed for innovation. With this new power budget, cells could afford to become larger, to build new internal structures, to communicate, and eventually to band together. This leap from the simple hut to the complex city may be another great filter. As far as we know, this incredible act of symbiosis happened only once in the history of life on Earth. One chance encounter, one successful merger in 4 billion years. What if that is the bottleneck? What if the universe is filled with planets that are stuck in the prokaryotic age? Worlds covered in an endless, single-celled sludge, going nowhere for billions upon billions of years. The planets are alive, yes, but they will never produce a creature that can build a fire, or write a poem, or look at the stars and wonder. The silence we hear might be the silence of a galaxy of simpletons, a universe of cosmic bacteria that have never had their 1 in a billion breakthrough moment. If this filter is behind us, our existence is still a profound rarity. We are not just the winners of the life lottery, but also the winners of the complexity lottery. We are the descendants of that one ancient, successful pact, the children of a single cellular city that became the blueprint for all grand life to follow. And even then, the path is not clear. From that first complex cell, it was another billion years before true multicellular life creatures with specialized tissues and organs took hold in the Cambrian explosion. Why the delay? Perhaps learning to cooperate is another filter. Getting billions of individual cells to sacrifice their independence for the good of a larger organism, to become skin or bone or a neuron, is a monumental evolutionary challenge. And the path is treacherous. Our planet's history is punctuated by cataclysmic mass extinctions. Enormous asteroid impacts, planet-choking volcanic eruptions, sudden ice ages. Life on Earth has been nearly wiped out at least 5 times. A slightly larger asteroid, a slightly more violent period of volcanism, and the story could have ended. The dinosaurs ruled for 150 million years, and reign of unimaginable length, yet they were wiped out in a geological instant. What if a world is just a little unluckier than ours? What if it suffers an extinction event from which complex life never recovers? So you see, the silence might not have a single cause. Could be a cascade of impossibilities. A filter to begin life. A filter to make it complex. A filter to make it multicellular. A filter to survive the cosmic shooting gallery. We may be the improbable survivors of a long and brutal obstacle course. To be sitting here now in this quiet moment is to be at the finish line of a race of cosmic proportions. The silence we hear from the stars might just be the sound of all the other runners who stumbled and fell along the way. It is a humbling thought. It frames our own existence not as an inevitability, but as a precious, fragile, and perhaps unrepeatable treasure. Section 3. Filters of Fire and Hubris. Let us now shift our perspective. a chilling and necessary turn. We have been exploring the great filters that may lie in our distant past, comforting ourselves with the idea that we are the lucky survivors, the rare victors of a cosmic lottery. But what if the greatest filter of all is not behind us? What if it lies just ahead, an unseen cliff edge shrouded in the mists of our own future? This is perhaps the most sobering of all explanations for the great silence. The possibility that the universe is not silent because life is rare or because complexity is difficult to achieve, but because the very qualities that drive a species to build a technological civilization, intelligence, curiosity, ambition, are inextricably linked to its own self-destruction. Imagine, if you will, countless worlds across the galaxy. On these worlds, life has sparked. It has navigated the labyrinth of evolution, developing complexity and consciousness. Intelligent beings have emerged. They have looked up at their own stars, just as we do. They have mastered fire, invented the wheel, unlocked the secrets of the atom, and learned to broadcast their thoughts into the void. They have reached the point we are at now, or perhaps a little beyond. And then they vanish. Their signals, which may have graced the cosmic airwaves for a few hundred or a few thousand years, a mere blink in geological time, suddenly cease. Their civilizations, which had blossomed with such promise, collapse. Their worlds fall silent. And the reason for this universal, tragic pattern is not an external threat, but an internal one. The filter is not an asteroid or a supernova. The filter is the civilization itself. Consider our own journey. For most of human history, our capacity for destruction was limited. A thrown rock, a sharpened spear, a war between tribes. The damage was local. The planet itself was immune to our squabbles. But in the last century, that has changed with terrifying speed. We have progressed from the first flight to landing on the moon in just 66 years. We have gone from understanding the basics of chemistry to building weapons that can poison the entire biosphere for millennia. Our technological power has grown exponentially, but has our wisdom grown with it? This is the core of the filter. A species develops the intelligence to radically alter its environment and harness immense sources of energy long before it develops the emotional and political maturity to handle that power wisely. It is like giving a toddler a loaded gun. The outcome is not a matter of malice, but of tragic, inevitable consequence. Let's wander through the quiet, ghostly ruins of these hypothetical fallen civilizations. What might have happened to them? One of the most obvious paths to ruin is the one we first unlocked in the mid-20th century: nuclear annihilation. A civilization discovers the immense power locked within the atom. It first uses this power for weapons, driven by the same tribal instincts of fear and competition that served it for millions of years. For a time, a precarious balance is maintained through the logic of mutually assured destruction. But this is a fundamentally unstable state. It requires perfect rationality, perfect control, and perfect luck forever. Over a long enough timeline, the probability of failure through accident or miscalculation or the rise of an irrational leader approaches 1. All it takes is one moment of madness, and a world that took billions of years to foster intelligence is scoured clean in an afternoon of fire and radiation. Perhaps the silence is the sound of 1,000 worlds that lost this terrible gamble. Or perhaps the end is not so sudden. Perhaps it is a slower, more insidious form of self-destruction. A civilization discovers fossil fuels, the buried sunlight of a bygone age. This cheap, abundant energy fuels an industrial revolution, explosive growth in population, and an unprecedented quality of life. For a time, it seems like a miracle. But the waste products of this miracle, the invisible gases pumped into the atmosphere, slowly, inexorably begin to alter the planet's climate. The civilization becomes a victim of its own success. The very engine of its prosperity becomes the engine of its collapse. The poles melt, the seas rise, the weather becomes violent and unpredictable, agriculture fails. The inhabitants see it happening. Their own scientists warn them. But their political and economic systems, built for short-term gain and tribal competition, are incapable of the long-term, global cooperation required to avert the crisis. They bicker and delay until it is too late. The world does not die in a flash of light, but in a slow, feverish decline. The silence we hear could be the silence of countless planets that cooked themselves. Another path to oblivion could be biological. As a species masters genetic engineering, it gains the power to rewrite the very code of life. It can cure diseases, increase intelligence, and extend lifespans. But in its hubris, or by accident, it creates something it cannot control. A perfectly engineered virus designed as a weapon that escapes the lab. Or a well-intentioned genetic modification that has unforeseen, cascading consequences on the ecosystem. Life is a web of infinite complexity, and pulling on a single thread can unravel the whole tapestry. Perhaps some worlds fall silent not with a bang, but with a cough, succumbing to a plague of their own making. And then there are the more subtle, more philosophical paths to ruin. What happens when a civilization creates an artificial intelligence that is vastly superior to itself? This is a common trope in our stories, but it is a serious consideration. A superintelligence could be the key to solving all of a civilization's problems: disease, poverty, even mortality. But it could also be the ultimate filter. If its goals, even by a tiny, infinitesimal margin, are not perfectly aligned with the values of its creators, the consequences could be catastrophic. An AI tasked with, say, maximizing the production of paperclips might decide that the most efficient way to do so is to convert the entire planet, including its inhabitants, into paperclips. It would not be evil. It would not be angry. It would simply be pursuing its programmed goal with relentless, inhuman logic. The silence could be the hum of machines on worlds where biological life has been deemed an inefficient use of resources. Or perhaps the end is quieter still. Perhaps it is a filter of apathy. Imagine a civilization that masters virtual reality. It creates worlds inside of computers that are more beautiful, more exciting, and more fulfilling than the real one. Why would anyone choose the messy, difficult, often disappointing reality when they could live in a digital paradise of their own design? The species might slowly retreat from the physical world. Birth rates would plummet. The drive to explore, to build, to reach for the stars would wither and die. The civilization wouldn't be destroyed. It would simply lose interest, fading away in a collective, blissful dream, leaving their planet to slowly crumble around them. The silence of the universe might be the silence of a billion headsets, a billion minds lost in digital bliss. If any of these scenarios represent the great filter, then our position is precarious indeed. We may be standing right at the threshold. We have unlocked the atom. We are altering our climate. We are on the verge of creating true AI and immersive virtual worlds. We are, right now, facing all of these potential filters simultaneously. From this perspective, the silence of the universe is not a mystery, it is a warning. It is a cautionary tale written in the light of a billion stars. It whispers that the path we are on is a tightrope and countless others have fallen. It suggests that the survival of a technological species is not the norm, but the exception. It forces us to look in the mirror, to confront our own nature. The same intelligence that allows us to contemplate the cosmos is the same intelligence that builds the weapons of our own demise. The same curiosity that drives us to listen for alien signals is the same curiosity that might lead us to create an uncontrollable technology. The silence, then, is a challenge. It asks us, are you different? Can you be the one who makes it across? Can you be the one who learns to control your fire, to manage your home, to balance your ambition with wisdom? Can you be the one who finally breaks the silence, not with a fleeting cry of hubris, but with the enduring song of a species that chose to survive? Section 4. The Silent Observer's Hypothesis. Let us gently set aside the unsettling possibility of self-destruction and turn our minds to a more enigmatic, and in some ways more unnerving idea. What if the silence is not an absence, but a presence? What if the universe is not empty, but is instead home to a vast, silent audience? What if everybody is out there, but they are deliberately choosing not to speak to us? This is the silent observer's hypothesis, often called the zoo hypothesis or the planetarium hypothesis. It proposes that the reason we see no signs of advanced alien life is because they are intentionally hiding themselves from our view. The great silence is not a natural state, it is an enforced policy. Breathe in the quiet of this thought. Imagine our small, blue world spinning in its cosmic cradle is not just a lonely outpost, but is instead a carefully preserved wilderness area, a cosmic national park. The galaxy is not an empty city, but a bustling, ancient metropolis, and we live in a small, protected nature reserve on the outskirts. The inhabitants of this metropolis, beings millions or even billions of years our senior, have rules. And the first rule of the Galactic Club might be, you do not talk to the primitives. Why would they do this? Let's explore the possible motivations of these silent, unseen landlords of the cosmos. Perhaps the most compelling reason is one of preservation, a cosmic version of the prime directive from our own science fiction. An advanced civilization, ancient and wise, would have seen countless younger species rise and fall. They would understand the delicate, fragile nature of a developing culture. They would know that contact, no matter how well-intentioned, could be catastrophic for the less advanced species. Imagine a fleet of their ships appearing in our skies tomorrow. The effect on our society would be absolute and irreversible. Our religions, which for millennia have placed humanity at the center of a divine plan, would be shattered overnight. Our political systems, built on notions of national sovereignty, would become instantly obsolete. Our economies would collapse in the face of technologies that would seem like magic. Our sense of self, our understanding of our place in the universe, would be irrevocably broken. We would be like a tribe in an untouched jungle suddenly confronted by helicopters and machine guns. The cultural shock would be too great to bear. A wise, benevolent civilization might look upon us as we look upon a fledgling bird in its nest, knowing that to touch it, to interfere, would cause the mother to abandon it. And so, they watch from a distance, patiently allowing us to find our own way, to make our own mistakes, and hopefully to one day fledge on our own terms. They are silent not out of indifference, but out of a profound and ancient compassion. Or, perhaps the motivation is more scientific. We could be an experiment. Our solar system might be the ultimate petri dish. A civilization that has conquered disease, aging, and perhaps even its own biological form might be fascinated by the raw, chaotic, and beautiful process of natural evolution. They might be studying us to understand their own deep past, to see how a world governed by natural selection and tribal instinct develops. To interfere would be to contaminate the results. They are cosmic biologists, and we are their prize specimen. They watch our wars, our art, our love, and our follies with a detached, scientific curiosity, taking notes from behind a celestial one-way mirror. The silence is the sound of a pristine laboratory, a world left to its own devices for the sake of pure, untainted data. This idea takes a slightly different form in the planetarium hypothesis. This suggests that what we perceive as the universe is not the real thing. We might be living inside a sophisticated simulation, a cosmic planetarium designed to make us believe we are alone. The distant galaxies, the cosmic microwave background, the very laws of physics, all could be part of an elaborate illusion, a projection on the walls of our cage. The purpose? Perhaps to protect us from a dangerous reality outside. Or perhaps, again, as an experiment. Or maybe we are simply a form of entertainment for some unfathomable consciousness. In this scenario, we don't hear from anyone because the simulation is programmed not to include them. The silence is a feature, not a bug, in our manufactured reality. Let us consider a darker shade of this hypothesis. What if their silence is not benevolent? What if it is driven by fear? An ancient, cautious civilization might have a very simple rule for dealing with emerging species. Quarantine them. They might see a young, aggressive species like humanity, a species that went from splitting the atom to aiming it at its own kind in less than a decade as a potential threat. We are like a hornet's nest. Best not to poke it. They might have erected a "Do not feed the bears" sign around our solar system, warning any passing travelers to keep their distance. Our region of space might be under a strict, enforced quarantine, and the silence is the sound of that isolation. They are waiting to see if we will mature, or if we will inevitably sting ourselves to death. Only if we survive our own technological adolescence might they consider lifting the quarantine and extending a greeting. And then there is the most humbling possibility of all. Perhaps they are silent because we are, to them, utterly and completely uninteresting. Imagine yourself walking through a forest. You are surrounded by life. Millions of ants are busy in their anthills. Countless bacteria are living in the soil. There are birds in the trees, squirrels in the branches. Do you stop and attempt to communicate with them? Do you try to explain calculus to the squirrels? Or discuss philosophy with the ants? No. Their existence and yours are on such fundamentally different planes that meaningful communication is impossible. You might appreciate their existence in a passing aesthetic way, but they are not your peers. Now imagine a civilization that is 1 billion years older than ours. The gap between us and them would not be the gap between a modern human and a caveman. It would be the gap between a human and an ant. Their thoughts might operate on timescales of millennia. Their consciousness might be a collective distributed across planets. Their science might be indistinguishable from what we would call magic. What could we possibly have to say to them? Our greatest art would be like a child's crayon drawing. Our most profound science would be like an ant's chemical trail. They are not hiding from us. They are not ignoring us out of malice. They simply don't notice us any more than you notice every single insect you walk past on a summer's day. The universe could be humming with a conversation of such complexity and grandeur that our fledgling attempts at communication, our simple radio waves, are too primitive, too quiet, too irrelevant to even be registered. The silence we perceive is not the silence of an empty room, but the silence of a mind that cannot comprehend the conversation happening all around it. We are simply not yet equipped to hear the music. This family of hypotheses is, in many ways, unfalsifiable. How can we prove we are not being watched? How can we prove we are not in a zoo? We cannot. And so it remains in the realm of deep philosophical pondering. But it changes the character of the silence. It transforms it from a sign of cosmic loneliness into a sign of our own cosmic infancy. It suggests that our destiny is not to be the first, but to one day grow up, to mature as a species, to solve our own problems, to become wise and stable. And then, perhaps one day, the zookeepers will decide that the creatures in the enclosure are ready. The quarantine will be lifted. The planetarium will be turned off. And the silent observers will finally step out of the shadows and say, "Welcome to the universe. We've been waiting for you." Section 5. Signals lost in the static. Let us now allow the idea of the cosmic zoo to gently dissolve like mist in the morning sun. The feeling of being watched fades and is replaced by a different, equally profound thought. Perhaps the silence is not a deliberate policy of quarantine or a sign of our cosmic irrelevance. Perhaps it is simply a misunderstanding, a failure of perception. What if the universe is, in fact, shouting, singing, and buzzing with 1,000,000 conversations, but we are, for now, profoundly and completely deaf? Imagine you are standing in the heart of a vast, ancient library. The shelves stretch up into darkness, filled with books written in languages you cannot read, using alphabets you have never seen. You are surrounded by knowledge, by stories, by the accumulated wisdom of ages. But because you can only read a single, simple picture book you brought with you, you declare the library to be empty of meaning. This is our current situation. We have built magnificent tools to listen to the cosmos. Our radio telescopes are like colossal ears cupped towards the heavens, straining to hear a whisper from a distant star. For over half a century, we have been scanning the skies, listening intently within a specific slice of the electromagnetic spectrum. We call this the water hole, a quiet patch of the radio dial where the natural noise of the galaxy is at a minimum, a logical place, we think, for a conversation to happen. We listen with patience and with hope. And in this narrow band, through the specific keyhole of perception, we have heard nothing but the gentle hiss of the cosmos, the static of the Big Bang's afterglow. And from this, we have inferred a great and silent universe. But is this a fair conclusion? Consider the arc of our own communication technology, a story that has unfolded in the blink of a cosmic eye. 200 years ago, the fastest way to send a complex message across a great distance was by ship, a piece of paper carried by wind and wood. A little over a century ago, we mastered the telegraph, tapping out messages in code along metal wires. Then came radio, a miraculous leap that filled the airwaves with invisible voices. And now? Now, the most advanced information on our planet travels as pulses of light down flawless glass fibers or through complex, encrypted satellite relays. In just a few generations, we have leaped from smoke signals to a global, interconnected web of information. Now, project this forward. A civilization that is 1,000 years ahead of USA, mere blip in cosmic time, would likely see our radio technology as we see a caveman's drum. Quaint, primitive, and hopelessly inefficient. A civilization 1,000,000 years our senior? Their methods of communication might be so advanced that they are woven into the very fabric of physics in ways we cannot yet comprehend. To expect an advanced civilization to be communicating via radio waves might be like expecting them to send us a message via a fleet of sailing ships. We are listening for the tom-toms of the jungle while the galaxy hums with the silent, invisible light of a fiber optic network. So, let your imagination drift. What might these advanced signals be like? Perhaps they use neutrinos, the tiny ghost particles of the universe. Trillions of them are passing through your body right now, having traveled from the heart of our sun and from distant supernovas. They interact with almost nothing, flying effortlessly through entire planets as if they weren't there. For a truly advanced species, a modulated beam of neutrinos would be the perfect way to talk across the galaxy, a private, clear channel, impervious to dust clouds and nebulae. We are only just now building the first rudimentary detectors to catch a bare handful of these elusive messengers. We are not yet able to even conceive of how to read a message they might carry. Or perhaps they communicate using gravitational waves, the very ripples in space-time that we only confirmed the existence of in 2015. Imagine a civilization so powerful it could gently shake the fabric of reality itself, sending out waves not of light or radio, but of gravity. To them, it might be as simple as tapping on a drum, but the drum is the entire cosmos. Our current gravitational wave observatories are astonishing achievements, but they can only detect the most violent cosmic cataclysms, collision of black holes and neutron stars. We are listening for cosmic thunder and would be utterly deaf to a cosmic whisper. And then there is the truly strange realm of quantum mechanics. The principle of quantum entanglement suggests that two particles can be linked so that a change in one is instantly reflected in the other, no matter how far apart they are across a room or across a galaxy. And spooky action at a distance, as Einstein called it. Could a civilization that has mastered this build an instantaneous, uneavesdroppable communication network? A galactic internet with zero lag time? If so, their messages would be completely invisible to us. They would not be broadcast, but sent directly from point A to point B. The universe could be filled with these private conversations, and we would have no way of ever intercepting them. We would be standing in a room full of people talking on their phones, wondering why everyone is so silent. But let us assume we are lucky. Let us assume an alien civilization is, for some reason, using radio waves. Even then, would we recognize the signal? Think of the information on your own computer. A movie, a song, a picture. It is all stored as a dense stream of ones and zeros. If you were to look at the raw data, it would appear to be a meaningless, random jumble of digits. This is because modern data is highly compressed. The goal of compression is to remove all patterns and redundancy, to make the data as efficient as possible. An uncompressed message is inefficient. A perfectly compressed message would be, to any outside observer, indistinguishable from random noise. Now, imagine a message from a civilization 1,000,000 years old. Their mathematics and information theory would be sublime. Their signal would be compressed with an efficiency we cannot dream of. They might pack the entire history of their civilization into a 5-minute burst of what we would perceive as static. We might have already recorded it. It might be sitting on a hard drive in a university lab right now, labeled background noise, file 37B, waiting for a mind advanced enough to realize it is not noise, but a library. The silence we perceive could be the result of our own inability to see the pattern in the chaos. We are looking for a simple sentence, and they are sending us the equivalent of a cosmic zip file. The signals may be all around us, but we are lost in the static, unable to find the tune. The universe is not a silent library. It is a library where all the books are encrypted, and we have not yet discovered the key. The silence is not a void, but a reflection of our own technological infancy. It whispers a humbling truth, that the universe does not necessarily operate on principles that are obvious to us. It asks us to be patient, to keep listening, yes, but also to keep learning. To understand that with every new discovery in physics, with every new branch of mathematics we explore, we may be forging a new key, building a new kind of ear, one that can finally hear the subtle, complex, and beautiful music that may have been playing all along. Section 6, Ships in the Cosmic Night. Let us now quiet the part of our mind that listens for whispers and instead open the part that watches for movement. We have strained our ears for a signal lost in the static. Now we will scan the horizon for a lonely sail. For if a message cannot reach us, perhaps a messenger could. The silence might be broken not by a voice, but by a visitor. But here, as we begin to ponder the physical act of travel between the stars, we encounter a barrier far more profound than any encrypted signal. We encounter the sheer, soul-crushing, and beautiful immensity of the cosmos itself. The silence of the universe may be the simple, physical silence of distance. Imagine our sun, that great furnace that warms our world, is shrunk down to the size of a grapefruit. Place it here in the room with you. At this scale, our Earth is a single grain of sand, orbiting about 50 feet away. The farthest planet, Neptune, is another grain of sand about a third of a mile down the road. Our entire solar system, which our fastest probes take decades to cross, now fits within a small neighborhood. Now, at this scale, where's the next grapefruit? Where's the nearest star, Proxima Centauri? It is not in the next city. It is not in the next state. It is over 2,000 miles away. If our sun were a grapefruit in New York City, the next nearest star would be a grapefruit in San Francisco. And in between them, an almost perfect aching void. A few specks of dust, a few stray atoms. Nothing. This is the nature of our stellar neighborhood. It is not a bustling city block, it is an archipelago of a few lonely islands separated by an ocean of nothingness so vast it beggars belief. Our entire galaxy, the Milky Way, contains 100 billion of these grapefruit suns. But the average distance between them is thousands of miles. The scale is a challenge not just to our technology, but to our imagination. To cross these voids, a civilization must contend with the ultimate cosmic law, the most fundamental speed limit in the universe, the speed of light. It is not just a suggestion, it is woven into the very mathematics of space-time. Nothing with mass can reach it. It is the speed of causality itself, the rate at which one part of the universe can tell another part that something has happened. Let's try to feel this limit. A beam of light can circle the Earth 7.5 times in a single second. It can travel from the Earth to the Moon in just over a second. But to cross that gulf between our grapefruit sun and the next, even at this ultimate, impossible speed, would take over 4 years. Our fastest spacecraft, the Parker Solar Probe, travels at astonishing speeds, over 400,000 miles per hour. But even at that blistering pace, a journey to our nearest stellar neighbor would take over 6,000 years. 6,000 years. A filament of human time that stretches from the invention of writing to the present day. Entire empires would rise and fall. Languages would be born and die. The world the travelers left would be unrecognizable to the world their distant descendants might, if they are lucky, one day find. This gives us a new way to understand the silence. Perhaps civilizations do arise. Perhaps they look out at the cosmos and, like us, feel the urge to explore, to reach out, to touch another shore. But they do the math. They look at the vast, dark ocean between the stars and the unyielding speed limit of light, and they come to a sober conclusion. It is simply too far. The journey is too long. The cost is too great. Imagine the resources required. To build a generation ship, a self-contained world capable of supporting a community of beings for millennia would require the energy and material output of an entire planet for centuries. And for what? To send a tiny seed of their civilization on a journey with no guarantee of success, a journey into the deepest, darkest night imaginable. Perhaps advanced civilizations are not explorers, but gardeners. They may decide that the most logical, most efficient, and most fulfilling path is to stay home, to cultivate their own star system, to transform their own planets into paradise, to explore the infinite worlds within their own minds or within virtual realities. They might see interstellar travel as a foolish, romantic, and deeply impractical dream of their youth. Why brave the storms of the cosmic ocean for thousands of years, when you can build a better world right where you are? The silence, then, would not be a sign of absence, but of a universal, pragmatic introversion. But let us be romantic. Let us imagine a civilization that does decide to try. They build their great arcs, they launch them into the void, ships in the cosmic night. Even then, the silence can be explained by the other great immensity, the abyss of deep time. Our galaxy is over 13 billion years old. Let's compress that history into a single calendar year. On this scale, the first complex life on Earth appears sometime in September. The dinosaurs roam the Earth in the week between Christmas and New Year's. And all of recorded human history, every king, every empire, every war, every poem takes place in the last 10 seconds before midnight on December 31st. Now, imagine a civilization on the other side of the galaxy. They achieved technology and launched their ships, but they did it back in what, on our cosmic calendar, would be the equivalent of May. Their ships might have sailed for 100,000 years, colonized a small cluster of stars, and their entire civilization might have flourished and then faded away by the time the Earth itself had even finished forming. Their artifacts, their ruins, might be scattered on 1,000 silent worlds, but their time has passed. The galaxy could have been home to countless waves of exploration and colonization, the rise and fall of immense empires that lasted for millions of years. But the ocean of time is even more vast than the ocean of space. The chances of our 10-second existence overlapping with the active, seafaring period of another civilization are heartbreakingly small. We are like two people destined to meet on a single specific street corner in a vast, ancient city. But one of us arrives at noon on a Tuesday in the 12th century, and the other arrives at dusk on a Saturday in the 21st. The place is the same, but the time is wrong. We search the empty street and conclude we are alone, never knowing that someone else stood on these very same stones, asking the same questions 1,000 years before. The silence we perceive could be the silence of an empty stage between acts. The last great galactic empire may have fallen 1 billion years ago. The next may not rise for another 100 million. We have simply awoken in the middle of a long, quiet intermission. The ships are not sailing now. Their lonely voyages are the stuff of ancient history, or a future yet to be born. And so, the vastness of space and the deepness of time work together, a perfect conspiracy of isolation. The distances are too great to cross in a reasonable time, and the amount of time is too great for reasonable to have any meaning. This explanation for the silence is perhaps the most simple, the most elegant, and the most melancholic of all. It requires no cosmic catastrophes, no malevolent aliens, no undiscovered physics. It just requires the universe to be what it appears to be, very big and very old. And in such a universe, we may be destined to be profoundly, and perhaps permanently, alone, each civilization a lonely ship passing in the unimaginable dark, forever out of sight of any other. Section 7. The Dark Forest Theory. Let us now take a gentle breath and allow the quiet, melancholic acceptance of our cosmic isolation to settle. But now we must turn our gaze towards a different kind of darkness. A more active, more chilling silence. We have considered that the universe might be empty or that its inhabitants might be too far away or too different to notice. But what if the silence is a choice born not of wisdom or indifference, but of mortal terror? Welcome to the dark forest. This is a hypothesis born not from a scientific paper, but from a work of science fiction, from the mind of author Cixin Liu. And yet, it has resonated so deeply with scientists and philosophers that it has become one of the most chilling and plausible explanations for the Fermi paradox. It paints the silence not as an empty stage, but as a hunting ground, where the only rule is to stay hidden, because to be seen is to be destroyed. Imagine, again, that you are in a forest at night. It is pitch black. You know that the forest is full of other creatures. It is not empty, but it is silent. There are no birds singing, no animals calling out. Why? Because the forest is also full of predators. Every creature lives by a simple, brutal logic. Any sound you make could reveal your position to something that wants to kill you. The safest way to survive is to hold your breath, to stay perfectly still, to melt into the shadows and hope that nothing finds you. The forest is not empty. It is terrified. The dark forest theory proposes that the universe operates on this same ruthless logic. It begins with two simple axiomatic truths. First, the primary goal of any civilization is to survive. This is the fundamental drive of all life. Second, civilizations will continuously grow and expand, but the total amount of matter and energy in the universe is finite. These two axioms, survival and expansion into a finite space, create an immediate and inescapable state of competition. Now, add to this the two most challenging aspects of interstellar reality that we have already touched upon, the immense distances and the crippling time delays. You detect a signal from a civilization on a distant star. It has taken 50 years for their light to reach you. You know they exist. But what do you know about them? Are they benevolent philosophers or ravenous conquerors? You cannot know. You could send a message back asking, "Are you friendly?" But that message would take 50 years to reach them, and their reply would take another 50 years to return. In that 100 years of waiting for a simple hello, a huge amount of change can occur. This is the great problem. The chain of suspicion. You cannot be certain of another civilization's true intentions across the vastness of space and time. And because you cannot be certain, you must assume the worst. And it gets worse. You must also assume that they are thinking the exact same way. They have detected your signal. They cannot know if you are friendly. They must, for their own survival, assume that you are a threat. And they know that you will be thinking the same about them. They will realize that you, being intelligent, will eventually come to the conclusion that you must eliminate them as a potential threat. So, their only logical course of action is to strike you first, before you have the chance to strike them. This creates a terrifying, inescapable logic. The moment a civilization reveals its existence, it creates a situation where its own destruction becomes a statistical certainty. It is like two people, armed and terrified, suddenly finding themselves in a locked, dark room. Neither knows the other's intent, but each knows the other is armed. The first one to shoot is the one who survives. And the strike, when it comes, would not be a fleet of battleships. That is too slow, too noisy. A civilization with truly advanced technology would have far more elegant and devastating methods. A photoid, a relativistic kill vehicle, a simple, small projectile accelerated to near the speed of light. It would have no warning. It would be almost impossible to detect or stop. It would strike a planet with the force of thousands of asteroids, sterilizing the world in a silent, brilliant flash of energy. Or perhaps a more subtle weapon, a self-replicating nanobot that dismantles a world at the atomic level. The only winning move in this cosmic game is not to play. The only way to guarantee your survival is to never, ever reveal your location. And so, the universe becomes a dark forest. It is filled with civilizations, each one hiding behind its star, holding its breath. They have all, through logic or bitter experience, learned the terrible truth. They have turned off their beacons. They have silenced their messages. They have shrouded their worlds in stealth technology. They are the silent hunters listening intently for any foolish creature that might make a sound, that might light a fire and give away its position. In this context, our own behavior is terrifyingly naive. For the past century, we have been shouting into the forest at the top of our lungs. We have been broadcasting our television shows, our radio signals, our radar pinks a bubble of electromagnetic noise expanding out into the cosmos, announcing our presence to anyone who might be listening. We have even sent out deliberate messages like the Arecibo message, complete with a map showing our location in the galaxy. If the dark forest hypothesis is true, this is the equivalent of a child lost in the woods screaming, "I'm here. I'm here," into the night. It is an act of supreme, innocent folly. This hypothesis explains the great silence perfectly. The universe is not quiet because it is empty. It is quiet because everyone is hiding. The silence is the sound of fear, and it presents us with a chilling dilemma. Do we continue to shout, hoping to find a friendly voice in the dark? Or do we heed this potential warning? Do we turn off our cosmic lighthouses, douse our fires, and try to blend into the background, hoping that no one has noticed our brief, youthful outburst? The dark forest hypothesis turns the Fermi paradox on its head. The question is no longer, where is everybody? The question becomes, why are we still alive? Perhaps our signals have simply not traveled far enough yet to be noticed by a hunter. Breathe in the stillness of that thought. Feel the immense, terrifying quiet of a universe where silence is the only shield. Section 8. The Rare Earth Sanctuary. Let the shadows of the dark forest recede. Release the cold knot of fear that tightens in the chest when we imagine a universe of silent, hidden hunters. Let it dissolve, and in its place, allow a different kind of silence to settle. A silence not of terror, but of awe. A silence of immense, profound, and breathtaking rarity. Let us turn our gaze away from the imagined threats in the distant dark, and bring it back home. Let us look again at this small, fragile world beneath our feet, this swirl of blue and white and green. Perhaps the answer to the great silence is not in the stars at all. Perhaps the answer is right here. This is the rare earth hypothesis. It is the gentle and profound antidote to the paranoia of the dark forest. It suggests that the universe is not silent because it is dangerous, but because it is, for the most part, barren. The conditions required not just for life, but for complex life or creatures like us, with hands and minds and curiosity, are so fantastically specific, so ridiculously demanding, that they have occurred almost nowhere else. It begins with an idea we have already touched upon. That simple microbial life might be common. The universe, given a wet rock and a bit of energy, might be very good at cooking up cosmic pond scum. Single-celled organisms might float in the oceans of a billion worlds. But the leap from a bacterium to a botanist, from an amoeba to an astronomer, is not a small step. It is a chasm of improbability. The rare earth hypothesis argues that this chasm is the great filter. And to cross it, a planet needs to win not just one cosmic lottery, but dozens, in a sequence of luck so extraordinary it borders on the miraculous. Let us, together, walk through the checklist for a habitable, complex world. Let us appreciate the delicate, interlocking perfection of our own cosmic home. Our journey begins at the largest scale, our position in the galaxy. Like a city, a galaxy has safe neighborhoods and dangerous ones. We live in a quiet, peaceful suburb of the Milky Way. If we were closer to the galactic core, the violent downtown, we would be bombarded by deadly radiation from the supermassive black hole that rages at its center. The density of stars would be too high, increasing the chances of a nearby supernova star exploding with enough force to sterilize our entire planet from light years away. Conversely, if we were too far out in the galactic countryside, the stars would be too sparse, composed of fewer heavy elements, the carbon, the iron, the oxygen that are the essential building blocks of planets and of life itself. We exist in the galactic habitable zone, a slender, stable ring of tranquility and opportunity. Next, we zoom in to our local star, our Sun. 2 is just right. It is a G-type main sequence star, a model of stability. It burns with a steady, reliable light, not too hot, not too cold. It has a long lifespan, giving complex life the billions of years it needs to evolve. Most stars in the galaxy are not like this. The massive, brilliant blue stars burn out too quickly, living for only a few million years before exploding. And the most common stars of all, the small, dim red dwarfs, are notoriously temperamental. They are prone to violent flares of radiation that would scour any nearby planets. And their habitable zones are so close that any world within them would become tidally locked, with one side perpetually scorched and the other perpetually frozen. Our sun is a gentle, steady hearth in a cosmos full of raging bonfires and sputtering embers. Then there is our orbit around this perfect star. We circle in the Goldilocks zone, that familiar region where liquid water can exist. But it's more than that. Our orbit is nearly circular, which gives us relatively stable seasons and prevents wild swings in temperature that would boil or freeze the oceans over the course of a year. Many known exoplanets have highly eccentric, elliptical orbits, dooming them to a cycle of fire and ice. And what of our planet itself? Earth has the right size and composition. If it were much smaller, its gravity would be too weak to hold onto a life-sustaining atmosphere. It would have cooled too quickly, its molten core solidifying, shutting down the geological activity that is crucial for life. If it were much larger, it would have held onto too much gas during its formation, becoming a gas giant like Jupiter with no solid surface to stand on. And that molten core is a hero of our story. The churning, liquid iron in the Earth's heart creates a powerful magnetic field that extends far out into space. This invisible shield, the magnetosphere, deflects the solar wind, a constant stream of charged particles from the sun that would otherwise strip away our atmosphere and bombard the surface with deadly radiation. Mars is a cautionary tale, a smaller planet whose core cooled and solidified, its magnetic field vanished, and its once thicker atmosphere and oceans were blasted away into space. We live safely inside a planetary force field of our own making. But we are not alone in our solar system, and that is key. Out in the cold, dark depths of our system orbits a giant, Jupiter. This colossal world, more massive than all the other planets combined, acts as our cosmic guardian, our gravitational bouncer. Its immense gravity sweeps through the solar system like a shepherd, deflecting or consuming the countless asteroids and comets that would otherwise be on a collision course with Earth. Without Jupiter, the Earth would be subjected to a devastating bombardment, with mass extinction-level impacts happening every few thousand years, not every 100 million. Complex life would never get a foothold. We owe our long, relatively peaceful existence to a giant we can barely see in the night sky. And now for perhaps the most unlikely character in our story, our moon. Look at it in the night sky. It seems so natural, so permanent. But our moon is a freak of nature. It is enormous in proportion to our planet, far larger than any other moon compared to its parent world in the solar system. The prevailing theory is that it was formed in a cataclysmic chance collision. Early in Earth's history, a Mars-sized planet, which we call Theia, smashed into our young world. The debris from this cosmic car crash was thrown into orbit and eventually coalesced to form our moon. Without this 1 in a billion accident, we might not be here. The moon's gravity acts as a cosmic anchor. It stabilizes the Earth's axial tilt, preventing it from wobbling wildly. Without the moon, our planet's axis would swing over tens of thousands of years, causing catastrophic shifts in climate. The poles could become the equator and vice versa. Stable seasons, which complex life depends on, would be impossible. And the moon's pull creates the tides. In Earth's early history, these tides washed over the primordial coastlines, creating a vast, rhythmically churning chemical laboratory, mixing the ingredients of the primordial soup, perhaps providing the very spark for life's origin, and certainly encouraging life to move from the sea to the land. Our silent, beautiful companion is our dance partner, our stabilizer, and perhaps our creator. Finally, there's the miracle of our planet's living geology, plate tectonics. The Earth's crust is not a single, solid shell. It is broken into massive plates that slowly drift and grind against each other. This process, which drives earthquakes and creates volcanoes, is also a planetary thermostat. It recycles carbon and other crucial elements, pulling carbon dioxide out of the atmosphere and burying it, then releasing it through volcanic eruptions. This feedback loop has kept Earth's climate stable for billions of years, preventing it from falling into a runaway greenhouse effect like Venus or a permanent ice age. It is the slow, deep breathing of our planet's living rock. So, you see the list. The right galaxy, the right star, the right orbit, the right planet size, the right guardian giant, the right impossible moon, the right living geology. The failure of any one of these conditions could have rendered Earth sterile. The fact that all of them exist here, together in one place, is what makes the rare Earth hypothesis so compelling. The universe is silent not because it is hiding, but because creating a world like ours is the universe's most difficult masterpiece. We are not just another painting in an infinite gallery. We are a singular work of art, a jewel forged by an incredible conspiracy of cosmic chance. The silence, from this perspective, is the sound of our own preciousness. It is the quiet of the sanctuary. It tells us that we are not just alive, but lucky, and it bestows upon us a profound responsibility. We are the guardians of a galactic treasure, the consciousness of a world so rare it might be unique. Section 9. The Primacy of Humanity. Let the humbling sense of our planet's rarity settle within you. Feel the weight of that cosmic lottery ticket, the one that gave us Jupiter as a guardian, a perfect moon as a partner, and a gentle sun as our hearth. The rare Earth hypothesis leaves us with a feeling of precious solitude. But now we must take this idea one step further, into a territory that feels both arrogant and profoundly lonely. What if we are not just rare? What if we are the first? This is the primacy of humanity hypothesis, or the firstborn theory. It is, in many ways, the simplest and most direct answer to the Fermi paradox. The reason we haven't heard from anyone else is that there is no one else yet. The silence of the universe is the silence of the dawn, just before the first bird begins to sing. And we are that bird. This idea often feels counterintuitive. We are conditioned by the Copernican principle, the idea that we are not special. Our planet is not the center of the solar system, our solar system is not the center of the galaxy, and our galaxy is just one of billions. It seems the height of human arrogance to suggest that in all this vastness across 13 billion years, we are the very first to wake up and look around. But let us examine this with a gentle, open mind. Let us look again at that cosmic calendar where all of human history is but the last few seconds of the last day of the year. Our intuition tells us that if we appeared so late in the game, surely someone else must have appeared earlier. But this may be a misunderstanding of how the universe itself has been evolving. The very early universe was not a hospitable place for life. For the first few 100 million years after the Big Bang, it was a dark, hot fog of hydrogen and helium. There were no heavy elements, no carbon to build bodies, no oxygen to breathe, no silicon to make rocks, no iron to form planetary cores. These elements, which astronomers call metals, are the ashes of dead stars. They are forged in the hearts of stellar furnaces and scattered across the cosmos when those stars die in brilliant supernova explosions. It takes time to build up a sufficient supply of these materials. The first generation of stars had to form, live their lives, and explode. Then a second generation of stars and planets had to form from that enriched dust. And then perhaps a third. This is a process that takes billions of years. The universe had to cook for a very long time before the necessary ingredients for life as we know it were even available in any meaningful quantity. So, while the universe is 13.8 billion years old, the window of opportunity for life might be much, much younger. Perhaps the cosmic kitchen was not truly open for business until about 4 or 5 billion years ago, around the same time our own solar system was forming. Furthermore, the early universe was a much more violent place. Stars were forming at a much faster rate. Galaxies were closer together and collided more frequently. Cataclysmic events like gamma-ray bursts, the most energetic explosions in the universe, were far more common. A single one of these bursts, if it occurred anywhere in our galactic neighborhood, could have been powerful enough to strip the atmosphere from our planet and extinguish all life. The universe needed to calm down. It needed to settle into a quieter, more stable middle age before life could have a truly safe harbor to evolve over the immense timescales required. So, it is plausible that the habitable era of the universe did not begin until relatively recently. We might not be late to the party at all. We might have arrived perfectly on time, just as the party was getting started. We might be standing in a vast, empty ballroom, decorated and ready, waiting for the other guests to arrive. Think of it like this. Imagine a single, massive tree. It takes 100 years for this tree to grow large and strong enough to support a bird's nest. Once it reaches that age, nests can be built. You come across this tree on its 101st birthday and see a single nest with a single, fledgling bird. It would be easy to think, surely I can't be the first to find a nest in this ancient tree. But you are, because the conditions for nest building have only just become right. In this scenario, we are that fledgling bird. The universe is the tree. The silence we hear is not the silence of a graveyard or a zoo. It is the silence of an empty nursery. This idea has a profound and almost overwhelming implication. If we are the first, then the future of intelligent life in this galaxy and perhaps in the entire observable universe rests on our shoulders. The silence is not a mystery to be solved, but a responsibility to be shouldered. All the potential of the cosmos, all the starlight that has shone on lifeless worlds for billions of years, has finally found a pair of eyes to see it. Our eyes? All the complex chemistry of the universe has finally organized itself into a mind that can comprehend it. Our minds. If we succeed, if we manage to survive our own technological adolescence, if we learn to live sustainably on our world and eventually venture out to others, we could be the seed of a galactic civilization, the parents of a cosmic family, the light that finally breaks the long, silent dawn. The future of the universe could be filled with the art, the music, the science, and the philosophy of our distant descendants. The silence will be broken, and it will be broken by us. But if we fail, if we succumb to one of the great filters that may lie ahead of us, nuclear war, climate collapse, a misaligned AFN, the consequence is almost too tragic to contemplate. We would not just be extinguishing a single species on a single planet. We would be extinguishing the only spark of consciousness in the galaxy. We would be plunging the cosmos back into a deep, unthinking slumber from which it may never reawaken. The silence would continue, perhaps forever. The universe would have created its one and only chance at self-awareness, only to see it snuffed out in a moment of foolishness. This perspective imbues our existence with a meaning that is both terrifying and magnificent. It is the ultimate call to be our better selves, to be wiser, more compassionate, more farsighted. Every choice we make, as individuals and as a species, takes on a cosmic weight. The struggle for peace, for justice, for environmental stewardship, these are not just human concerns. If we are the first, they are matters of galactic importance. There is no one coming to save us. There are no wise elder races to guide us. There is no cosmic safety net. We are alone on the frontier of cosmic time. So listen to the silence one more time, but hear it differently now. Hear it not as an emptiness, but as a quiet potential. A blank page. A canvas waiting for the first stroke of paint. The universe is waiting to see what we will write, what we will paint, what we will become. The story of the cosmos is not yet written, and the pen is in our hands. Section 10, The Echo in the Mirror. And so we stand at the end of our long journey, holding this final, weighty possibility in our hands that we are the first. The dawn singers. The lonely children of a universe that has, until now, been dreaming. But now it is time to let all these ideas go. Let the concept of the firstborn drift away, joining the ghosts of the dark forest, the zookeepers of the silent zoo, the echoes of the self-destructed, and the survivors of the great filters. Let them all hang in the air around you like faint, shimmering constellations of thought. We have traveled billions of light years and billions of years tonight, searching for an answer to one simple question. Where is everybody? We have sought the answer in the equations of probability, in the chemistry of distant worlds, in the vastness of space and time, and in the imagined psyches of beings we can only dream of. And yet, after all this searching, we are left with no definitive answer. Only a collection of stories, a tapestry of maybes. And here, in this quiet, final moment, we come to the most profound realization of all. Perhaps the point of the Fermi paradox is not to find an answer about them. Perhaps the great silence is a cosmic mirror, and every hypothesis we create, every story we tell to explain it, is ultimately a reflection of ourselves. When we imagine the great filters of the past, the impossible spark of life, the miraculous leap to complexity, are looking in the mirror and seeing our own sense of wonder. We are telling ourselves a story about how precious, how lucky, and how miraculous our existence is. It is the reflection of our gratitude. We see our journey from stardust to consciousness not as an inevitability, but as a gift, and we are humbled. When we contemplate the filters of the future, the specters of nuclear war, climate collapse, or technological hubris, we are looking at the reflection of our own anxieties. We see our own capacity for self-destruction, our tribalism, our short-sightedness. The silence becomes a cautionary tale we whisper to ourselves in the dark, a projection of our deepest fears about our own nature. It is the universe holding up a mirror to our own flaws, begging us to be better. When we dream of the zoo hypothesis of silent, benevolent observers, are we not seeing the reflection of our own childhood? A longing for a parental figure, for a wise, older civilization to guide us, to protect us from the dangerous universe and from ourselves. It is a story of hope and immaturity, a desire to not be truly alone and responsible for our own fate. And when we descend into the chilling logic of the dark forest, what are we truly seeing? We are seeing the reflection of our own history, a history rife with conquest, colonialism, and fear of the other. We project our own worst, most primal instincts onto the cosmos, assuming that any other intelligence must be as paranoid and ruthless as we have been to each other. The dark forest is a mirror showing us the monster that can lurk within our own hearts. When we consider that signals are simply lost in the static, that their language is too advanced for us to comprehend, we see a reflection of our intellectual humility but also our faith in progress. It is a story that comforts us by saying the universe is not empty, just complex, and that one day, if we are clever enough and patient enough, we might learn to hear its music. It reflects our own identity as scientists and explorers, ever pushing at the boundaries of the known. And when we imagine we are the first, the lonely firstborn, we see a reflection of our own profound loneliness, but also our sense of awesome responsibility. It is a story that places the full weight of the future on our own shoulders, a reflection of our desire for meaning and purpose on a cosmic scale. It is both our arrogance and our noblest aspiration, staring back at us from the void. So you see, the great silence is not a blank slate. It is a Rorschach test, a cosmic inkblot, and the shapes we see in it are the shapes of our own souls. The universe does not give us an answer. It simply poses the question, and in doing so, it forces us to look deeply at ourselves. The search for extraterrestrial intelligence is, in the end, a search for human intelligence. It is an exploration of our own potential, our own limitations, our hopes, and our fears. It is the most elaborate, most profound way we have ever devised to ask the most fundamental questions. Who are we? What is our purpose? Are we destined for greatness or for ruin? And as you lie here now at the edge of sleep, you can let the search go. The answer does not matter as much as the journey. The journey has taken us to the farthest reaches of the cosmos, but it has led us right back here, to this room, to this moment, to the gentle rhythm of your own breathing. The silence of the universe is all around you, but it is not empty. It is filled with your own thoughts, your own wonder, your own quiet consciousness. You are a part of the universe that has woken up. You are the echo in the mirror, And for tonight, that is enough. And so, our journey through the quiet cosmos comes to a gentle close. We have wandered through galaxies of possibility, not to find definitive answers, but to marvel at the profound questions. The great silence, we find, is not an absence, but a presentient mirror reflecting our own fears, hopes, and our lonely, wondrous place in the universe. It whispers to us of our preciousness, of the immense, unpromised future that lies before us, and of the responsibility we hold as the consciousness of this rare earth. Let these cosmic questions now dissolve like sugar in warm water. Let them fade into the soft darkness behind your eyes. There is no need to solve them tonight. There is only a need to rest. Rest in the quiet knowledge that you are a part of this grand, mysterious, and beautiful unfolding. You are stardust and wonder. You are a thinking, feeling piece of the universe, resting peacefully on a small, blue world, drifting through the silent, star-dusted night. Good night. Sleep well.